morning, children. In today's class, we are going to learn about various applications of conic sections. In the previous class, we learnt about parabola, ellipse and hyperbola, the various equations, formula and the parts of a conic I can say. Now, there is a question for many of you. Why should we learn all these things? Don't you all see these shapes in practical life? Just think out. See a parabola which is in the shape of opening up, U-curve I can say. Where have you seen this? Whenever you go around, you could have seen cables hanging like this way. Similarly, bridges, suspension bridges, all these things are hanging like this way. Now, is that only the case? You have dish antenna on the terrace of your home. You have beautiful arches in every construction, not only your house, you can see all these beautiful arches in bungalows. And the most important idea, some of you are talking when I'm taking class and I'm disturbed. So I just want to make you to concentrate. I'm just throwing the chalk piece on you. Can I throw straight on you? No, that is not the case. Anything that is thrown, how does it go? The chalk piece goes up and fall on you, isn't it? That is the idea of any projectile. In physics, you would have learnt about projectiles. Anything that is projected follows an upward motion and finally it falls down, and definitely it is a parabola. So the rocket that is projected from space station or even a cracker, the rocket that we do it during Diwali season, even that follows a parabolic path. Now that you can guess what all we throw definitely goes. We always throw many things, isn't it? Something useful, something not useful, and anything that we throw, it goes up in the air like a parabola and then only it falls down. So all the falling bodies in the universe are connected with this parabolic path. The next idea, I can say anything that flows from a pipe. See, a water fountain I can say, you could have seen in many theme parks. Or even in your home, you could have had a pipe. Okay, water flows from a pipe. How does it go? This is a pipe end. Water flows like this way. And even this is following a parabolic path if I complete the other side. So remember, flowing things and then thrown things. These are the things that we see in practical life, day-to-day life situations. And so, learning parabola is quite an important thing. Now, all of us have vehicles at home, isn't it? Have you ever analyzed the headlight of the vehicle? It will be like this. And the bulb is kept somewhere here. It is not kept, it is not fixed there. It is little bit in front. That is the focus, I say, what we learnt in the previous class. So in the focus of a parabola, the bulbs are kept so that even in distant place, the lorry or any vehicles are coming in night time, we can see the light is growing stronger and longer. Even from a distant place, I could guess some vehicle is ahead. So I can think and I can adjust my traffic according to that. So in all the motor vehicles, in all the focus lamps, the bulbs are kept at the focus for effective functioning. Is that all? Like this, we can keep on telling. Now it's time for you to start analyzing where and how these concepts are applied. Well, we have some exercise problems which we will discuss in detail so that you can check on your own way how you can apply these concepts in your practical life situations. Ellipse, the next important concept I can say. In ellipse, it is an elongated circle we say. So this elliptical part, whenever we say, immediately what comes to your mind? The solar system. Our mother planet, Earth, is moving around the sun with keeping sun at the focus. Okay, all the planets are moving in an elliptical orbits, we say. Is that all? Where does a hyperbola being applied? The hyperbola, when I say, people used to say it is like this shape. Okay, so wherever you see in big production units, the nuclear power plants, all these things are in the shape of a hyperbola. We will study in detail in the exercise problems. So most interesting and most repeated questions in our examination. Pay attention and learn well. Exercise 5.5. We are going to do problems based on applications of conic. Parabola, the shape of an arch, the shape of a bridge. These are some examples for parabolic shapes. Here, a bridge has a parabolic arch that is 10-meter height in the center. So, arch we have drawn opening downward. 10-meter in the center tells me this is 10, and for this problem let us take the vertex to be a, 0. This is x-axis, y-axis, where the height, the peak point is at the vertex, which is 0, 0. 30-meter wide at the bottom. This is the bottom. 30-meter wide tells me 15 plus 15. So this is 15 meter and this is 15 meter. Together they form 30-meter width. The question is, find the height 6 meters from the center. Now, with the given conditions, let us see what all we can write. A parabola facing downward. We write the equation x square is equal to minus 4ay. Call this as number 1. Now, every practical problem, we have to identify a point on the curve. Look, I can write this point. The x value is this and the y value is this. So what is x value? 15. And what is y value? 10. Once I write it, check the symbols. X is in the positive side, but y is down below 0, 0. So I will put minus 10. So this is 15, minus 10. Substitute the point in the equation. So let us say from the diagram. So when you are not able to write many statements, better use this word from the diagram. 15, minus 10 lies on 1. What do you mean by lying on 1? It must satisfy the equation. So wherever x comes 15 and wherever y comes, let us put minus 10. Simplifying, 225 is equal to 4 into a into 10, or a is equal to 225 divided by 40, or I can write 4a is equal to 225 by 10, which is 22.5. Putting this back in first equation, we get x square is equal to minus 4a value is 22.5 into y. Now back to the question. So 3 parts we have completed. Read the question, draw the diagram. Frame the equation. Find a value using a point on the curve. So 3 steps are over. Now, what is expected actually? Find the height 6 meters from the center. So this is totally 15. From the center, 6 meters. So this is my question. 6 meters from the center, what is the height of it? Now we can find only the small height. So what is this question mark? It is total height minus this value. Well, so let us write down 10 is the total height. My required height is 10 minus y. What is the x value given? 6. 6 comma y1 lies on this equation. X square equals to minus 22.5 into y. Substitute x value 6 means 6 square is minus 22.5y, or y is equal to 36 divided by 22.5. Negative symbol tells me it is below the x-axis. Divide and write the answer. Minus 360 by 225, multiplying up and down by 10 and simplifying by 6 table, 5 table, 3 table, all that, we get the answer minus 1.6. This small height is 1.6. So what is the required height? Let us subtract from 10. The required height is nothing but 10 minus 1.6. 1.6 tells me the small height below the x-axis on the curve, this small thing. But I want this height from the flooring, which is nothing but 10 minus the value. So 10 minus 1.6 gives me 8.4 meters. So the height of the arch 6 meters from the center is 8.4 meters. So in all the word problems, give the answer in statement. Whatever they have asked you, write according to that. Height of the arch 6 meter from the center is equal to 8.4 meter, and that is the answer. Question number 2. Semi-elliptical opening in a tunnel. So we have drawn the tunnel's opening as a semi-ellipse. As soon as I read the word ellipse, I must write the equation of an ellipse, which is x square by a square plus y square by b square equal to 1. What is a? This length, major axis, this side a comma 0 and this side minus a comma 0. In standard problems, when they have not given anything, we can take 0, 0 as the center. So we know semi-ellipse will also have the same equation. It's a part of the ellipse. Now, width of the highway is 16 meters. So this black part is the highway. What is given? 16 meters tells me this is 8 and this is also 8. So the width of the highway is 16, tells me 8 this side and 8 the other side. Height of the edge of the road must be sufficient for a truck of 4 meter high. So this is a truck, let me say the height is 4. Immediately I can write the point of it. X value 8 and y value 4. So what is the point that I get? 8 comma 4. So whenever we write an equation, immediately we must try to plot a point on the curve. What is given? If the highest point of the opening is 5 meters, this is the highest point, and so let me call this as some B. CB equals to 5 meters approximately. So CB tells me it is the length B and AA dash is nothing but 2A. Remember, that is the major axis. AA dash is 2A and CB is the height that I call B. In this question, A is not given. We have to find out A. What is the question? How wide must the opening be? So this opening's width only is asked. The width is nothing but AA dash and A dash is nothing but 2A. So we have to find out what is 2A. This is the question. Now coming back here. What all we know, let us write down. Since it is semi-elliptical opening, we have written the equation as x square by a square plus y square by b square equal to 1. Here, a value we don't know, but b value is 5. Substituting 5 here, x square by a square plus y square by 25 is equal to 1. It is passing through 8, 4. So call this as 2. 2 passes through the point 8, 4. What does it mean? Wherever x comes 8 and wherever y comes 4 equals to 1. Try to simplify this equation. 8 square, 64 by a square plus 16 by 25 equals to 1. Or we get 64 by a square is equal to 1 minus 16 by 25. 64 by a square equals to 25 is the LCM. 25 minus 16. 64 by a square is equal to 25 minus 16 is 9 by 25. So this implies a square is equal to cross multiply 64 into 25 divided by 9. My question is 2a. So what is a? Root of 64 into 25 by 9, which is nothing but 64 square root 8, 25 square root 5, 9 square root 3. So we get a equals to 40 by 3. Or my required width is 2a, and 2a is 80 by 3. As we divide, we get 26.666 it goes, or 67 meters approximately. So this is the answer. We'll see the question again. It is a semi-elliptical opening. So we write ellipse equation taking center as the origin 0, 0. They have given highway is 16 meter width. So this is the highway taking 8, 8. Height is given to be 4 for the highway. So this is 4. The opening highest point is 5 meters. So we will say the highest point is nothing but B value. So B value is 5. Now we need to find what is the width of it. The width is nothing but 2a, and my question is 2a. So we will substitute what all we know in equation 1. B we have substituted. It is passing through the point 8, 4. As I substitute and simplify, we get a value is 40 by 3, and so width is nothing but 2a, which is 26.67 meters. Question number 3. At a water fountain, water attains maximum height of 4 at horizontal distance of 0.5 from its origin. As I read the problem, let me say the water fountain is here. This is the mouth of the water fountain. Treating this as the origin. From here, the water goes on like a parabola. We know in all the fountains, water goes up to a certain height and then it falls down. As I see, this is the maximum height. What is given maximum height? 4. So if I join, this height is nothing but 4. The next idea, when it is attaining the height 4, the horizontal distance is 0.5 meters. So when it is 0.5 meters, it is attaining a height of 4. The next idea, path of water is a parabola. Of course, we know every water fountain goes falling down. So it is opening downward. This point we have to identify as the vertex. So what is the vertex if I treat this as the vertex? This is 0, 0. What is x value? 0.5. And what is y value? 4. So vertex we know 0.5, 4. Whenever the vertex is different, how will you write equation of the parabola? It is opening down and it is an equation of parabola. We write x minus h the whole square equals minus 4a into y minus k, where h comma k is the vertex and here the vertex is 0.5, 4. So let us restructure the equation. X minus 0.5 the whole square equals minus 4a into y minus 4. Call this as equation number 1. So from the first statement, I am able to identify the equation of the parabola. The second statement, find the height of the water at a horizontal distance of 0.75. Up to this is 0.5. So the remaining here it will be. The question is, this width is 0.75 and what is y1? This height only is the question. How to find it out? Before that, we know the curve originates from 0, 0. That is the origin. Origin we call 0, 0. So the curve originates from, that implies the curve is passing through 0, 0. So 1 passes through. Let me say equation 1 passes through the origin. What is the origin? 0, 0. So wherever x and y are coming, put 0, 0. So I get 0 minus 0.5 square minus 4a into 0 minus 4. Redefining, it is 0.25. 4 into 4, 16a. Or I can say a is equal to 0.25 by 16 or 4a is equal to 0.25 by 4. Mostly we need 4a to be substituted. So no need even to get a. We shall do only 4a in such problems. Putting this back in first equation. X minus 0.5 the whole square is equal to minus 4a value is 0.25 by 4 into y minus 4. Now what is actually the question? When x is 0.75, what is the height of it? Or I will say 0.75, y1 lies on the equation. 0.75, y1 lies on this equation. So substitute. Wherever x is coming, put 0.75. This write 2 decimal, easy to subtract. 0.5 rewrite as 0.50 minus 0.25 by 4 into y minus 4. 0.75 minus 0.5 is 0.25 the whole square equals to minus 0.25 by 4 into y minus 4. 0.25 I can cancel. Cross multiply. 4 into 0.25 is 1 equals minus y. Minus into minus is plus 4. Bring y here, 1 here. Y equals 4 minus 1, that is 3. What is the question? Height of water at the horizontal distance. So write the statement, put is equal to 3 meters. So in all the statement problems, give the answer as a statement. Height of water at a horizontal distance of 0.75 meters is 3 meters. Let us remember, whenever the vertex is different, parabola opening down will have the equation x minus h the whole square equals minus 4a into y minus k. H comma k being the vertex of it. Substitute and a point on it, I can say 0, 0. Putting that we get 4a. Then if 0.75 is x value, what is the y value? So find out that y value, put y1 everywhere. That y1 value is my answer. Question number 4. A satellite dish is designed as a parabola. The dish is 5 meters wide at the opening. You all have seen a parabolic dish. The opening, this is the opening. It is 5 meter wide at the opening. Tells the total height is 5. So 2.5 above and 2.5 below. Origin is at the vertex. The focus is placed at 1.2 from the vertex. So 1.2 is nothing but A value. Remember, focus is at A distance. So from the vertex, the focus is at 1.2 meters. Tells me A equals 1.2. The parabola is opening to the right. Origin at the vertex, axis of symmetry, that which divides into two equal parts, that is x-axis. All this together tells me the equation is y square equal to 4ax. What is a actually? 1.2. So let us substitute. Y square equals 4 into 1.2x, or y square equals 4.8x, the equation of the parabola. So the first question is find the equation of the parabola, which we have found out as y square equal to 4.8x. The second part of the question is find the depth at the vertex. Depth at the vertex means this full thing we need. So call this as x1. I don't know this depth, but I know the height, that is 2.5. So what is this point then? It is x1 comma 2.5. So we will say x1 comma 2.5 lies on y square equal to 4.8x. That is y value I have to put 2.5. So I can put 2.5 the whole square equals 4.8 into x, or x is equal to 2.5 the whole square is 6.25 divided by 4.8. Let us divide and write the answer. Equals to 1.3 meters. You can divide it by multiplying by 100 or take logarithm and find out the answer. So it's a simple problem where they have given everything. Read line by line, understand what it is. It's a parabola opening to the right because origin is at the vertex and axis of symmetry x-axis. We have to know equation of the parabola is y square equal to 4ax. A is attained from focus distance, that is 1.2. Then we know this and this will be this coordinate. Call this as x1 and this is 2.5 from the question. x1 comma 2.5 lies on the equation, gives me x is equal to 1.3 meters. So we will take and write the answer. Depth at the vertex is 1. Depth at the vertex equal to 1.3 meters, and that is the answer. Question number 5. Parabolic cable of 60 meter portion of the road bed. The diagram is given in the question. Each portion, the length is 6, so that together they form a 60 meter portion. Vertical cables are spaced 6 meters along this. Find the lengths of 2 of these cables from the vertex. Let us treat this vertex as 0, 0. They have given 3 meters in the question. So this tells me 0, 3 is the vertex of this parabola. It is opening upward. Opening upward, how will you write the equation? X minus h the whole square equals 4a into y minus k, where vertex h comma k equals 0, 3. Replacing x minus 0 the whole square is 4a into y minus 3, or I write x square equals 4a into y minus 3. First part of the question is over. Call this as 1. Now, I must find out a point on the curve. In the question, they have given the diagram. This height is given to be 16. So, the height is 16 and each cable is of the length 6. So, 1, 2, 3, 4, 5. So, 5 into 6, 30. X value 30, y value 16. So, what will be the point on it? 30, 16. So, we will say from the diagram, 30, 16 lies on 1. Substituting 30, 16, 30 the whole square is 4a into 16 minus 3. So 4a equals 900 divided by 13. So equation number 1 will now become x square equals 900 by 13 into y minus 3. Now, what is the question? We need to find the lengths of the two of these cables from the vertex. From the vertex, first cable, let me say. Each cable, they have given 6 meters spacing. So, first cable, x value will be 6. What is y value? Putting it in the equation, 6 square equals 900 by 13 into y minus 3. Cross multiplying and simplify what is y. Cancelling 6 table 6 times. 150 times. Again I can cancel. Y equals 3. Simplifying this we get 52. So y equals to 3.52. For the second cable, x is equal to first cable 6, second cable 6 plus 6, that is 12. And what is y? The same equation, let us substitute. 12 square equals 900 by 13 into y minus 3. Again rearrange and simplify the answer. So 144 into 13 divided by 900 is y minus 3, or y is equal to 3 plus. We can cancel with 12 table, simplify the answer. 12 12s are 7 into 5, 75. Again I can cancel. 4 3s are 25 3s are. So we get 52 by 25. Divide and write the answer. It is 3 plus 2.08, that is 5.08. And each time we put the units meters. So the first cable, the height is 3.52 meters, and the second cable, the height is 5.08 meters.